Right, is go.
Okay, so high performance liquid chromatography, right?
Right.
Is the name of the process they use in my college. And chromatography is simply a separation of chemicals. And I was in there for like 3 months before I actually just looked it up on the internet and found out that's what it was. I used to think it was...
Well, you were working for them and you didn't know.
Yeah, I didn't know.
Brilliant.
I'm an engineer, so they just tell me we need this and I try to get it done.
You shut up.
But I don't actually necessarily have to understand what the chemists are doing.
Okay.
But anyway, I thought chromatography was you shine light through it and the different elements will absorb different amounts of different wavelengths of light, and you can understand by what wavelength, the quantities of wavelengths of the light coming out. You can look at that and reference it to what you sent in and see how much it gets absorbed, and you can see what chemicals is made of. That's what they do with planets. Like you look at a planet and you look at the starlight coming from behind it and you can see what wavelengths of light is
So
missing.
when did this hydrophobia, is it hydrophobia?
Oh yeah,
Is that
okay,
the
so...
thing? When did that come into it? Because to me that just sounds like the fear of water.
Hydrophobic.
I love it.
Yeah. So we pass the chemical samples through a monolith, which is just a sort of spongy... It's a hollow... Yeah, it's like a spongy chemical, all the same thing.
Alright, I thought a
like
monolith was like a large sculpture.
A crunchy bar.
Okay.
This is what they call it, a monolith.
Right, got it.
It's hollow.
So it's not a large sculpture, it's a crunchy bar.
Yeah,
Okay.
it's a hollow, it's a substance and it's got a really high surface area. That's what it's necessary
Right.
about.
Which is why it's exactly like a crunchy bar.
Yeah, and they're always working on ways to increase the surface area so they can reduce the size of the monolith necessary. Okay, and so it passes through the monolith, and the monolith is hydrophobic. Okay, and they pass through a sample, and all the hydrophobic chemicals within this sample will get stuck onto the monolith, and so the least hydrophobic chemicals will get attached on early. So okay, all the non-hydrophobic stuff just comes out at the beginning in a huge, just a spike on the graph, and then the less hydrophobic stuff.
Somewhat like a scientific mohawk.
Yeah, well, it's just a
It is
spike,
spiky, yeah.
and then another,
I got spikes.
like
So,
like,
yeah. So it's the same shape
then-
as mohawk.
and
Got
the
that.
size of the spike corresponds to how much of the sample there is.
I get everything.
And then so it goes in order, like the least hydrophobic thing gets knocked off early, and then there's the next hydrophobic thing, and then there's the next hydrophobic thing, and the next hydrophobic thing. And then at the end there's another sample, is like a chemical that will be passed through just to clear off the monolith of all the remaining sample, and then you know what it looks like, and you know when it comes through.
Just looks
that
like
you've
someone
done.
with a mohawk.
And then, so it'll get separated out into different vials, glass vials, and then it gets sent off to mass spectrometer,
Right.
which ionizes the sample. Okay.
Oh yes, ionization. I do love it. I love a bit of
Which is
ionization.
basically ionization
Yes.
means it
Glad we've
gets,
got there.
an extra electron, added or removed, I'm not sure, but it gets an electric charge, right? And so you accelerate it, it vaporizes it and ionizes it at the same time, and it
But when
accelerates
do the furry animals come into the story?
It's their blood that we're analyzing.
Okay, well, at least there's furry animals involved.
And so then it gets accelerated down a vacuum chamber, and then it gets passed through an electric field, right? And then it passes through the electric field, and the electric field exerts a specific force per electron, so all the chemical, so this chemical that you're analyzing, like this, the separated chemical, the separated parts of it are all the exact same molecules, right? So then you are analyzing them to find out what those molecules are, and so you put a positive or negative charge on it. Actually, it's a negative charge because it's an extra electron thing. Then you pass it through the electric field, and the force that gets exerted on each molecule is the exact same. So they're going to go pass through this electric and they're going to move, and the heavy things will get moved a little bit, and the lighter things will get moved a lot. And you can see by how much it gets moved that it will just be like if you can imagine a wall where like to the left side is the heaviest thing and to the right is the lightest thing, and then you can look at the periodic table of elements and you can see
Oh God.
how
So we're
heavy
just
it is,
assuming that you happen
and
to
then
have
you
a
know what
periodic
it's made
table
of.
lying around that you can look at, because otherwise this is all. If you,
Well, it's in a, like this is
Is
a
it-
million
We're
euro
in a lab,
piece of
aren't we?
machinery, so you're gonna have it mass. You're gonna have a
Yeah.
periodic table.
yeah, I guess that's probably the least of your
And
concerns.
that's a very
Someone's gonna have an
simple
iPhone, they're just gonna
explanation
Google
of
it.
how you.
That is very simple.
Analyze.
Well, it's good. Okay, I'm glad I have this on camera because now I'm gonna listen about 10 times later, and
I'm not sure how good that is.
I'm still just gonna use the words.
My
I've
dad
learned
does
from
mass
it.
spectrometry, so that's why I've learned what that is.
My dad does lawyering, and I don't know how to lawyer.
Yeah.
Well, thanks for that, Steve.
Cheers.
It's been nice interviewing you.
Science over.
Yes. Drink.